All right, perfect. So here's what we're going to do. We are going to talk today about graphing rational functions. Guys, let's talk about what is a rational number. Any number that can be written as a fraction. Very good. Any number that can be written as a fraction is a rational number. So a rational function is any number that can be written in the form p of x over q of x, or any function that can be written as p of x over q of x, where p of x and q of x are polynomials. But we really have to be careful in this chapter because we know whenever we have fractions that the denominator is not allowed to be what? 0. Okay? 0. So when we had the inverse variation, y equals a over x, that was a rational function. That was a rational function. Okay? Now, it goes on. This is the parent rational function. It's funny. Mrs. Franjezovic was just talking to me about her physics classes, and she said, do you use the word parent function? And because somebody said something parent function, and she says, so you do use the word parent function? I said, yes, we use the word parent function. She goes, my juniors and seniors said they have never heard that word or that expression before. I'm thinking, we always use the word parent function. So yes, this is it's the most basic function in this family. You have quadratics, y equals x squared, linear, y equals x, square root, y equals square root of x, and cubic, y equals x cubed. So those are the parent functions, the ones that have the most basic principles, and then we're going to shift them up, down, left, right, flex, reflect, stretch, the whole 9 yards. All right, so this is the most basic rational function. So let's kind of think about this, and let's go through, and let's make this a table of values. So what do you guys get when you plug in -3? -1/3. How about -2? -1/2. How about -1? -1. How about 0? What's 1 divided by 0? It's not 0. Error. Okay. So in math, we call that error undefined, right? Undefined. Hi there. Undefined. Very good. Your notes are in the folder. I already put them on there. Let me mark you as here. I wondered where you went. And now you're back. Okay, and now we're back here. All right, so again, that is undefined. What is 1 over 1? What is 1 over 2? And what is 1 over 3? 1/3, and so on. So if I were to come over, and when I come over and graph these, okay, we're going to come over to -3. And I have -1/3. And then at -2, I have -1/2. At -1, I have -1. Okay, let's do another, like, what would I have put if I put, like, -8 in? I'd have -1/8. What about -10? -1/10. What about -100? Is it ever going to go past 0? No. And what about going this way? What if I put -1/2 in? Well, what is 1 over -1/2? -2. All right. What is 1 over -1/3? -3. So, and so on. So is it ever going to go? Can it be 0? We just said at 0, it's what? Undefined. So this branch looks like this. That shouldn't curve back in. It kind of started curving back in. Let me fix that. I don't like that. Okay, it goes like this and like this. And now the branch on the other side is the same way. At 1, I have 1. At 2, I have 1/2. At 3, I have 1/3. And it would keep going. And then at 1/2, I'd have 2. And it also comes along like this. So this branch looks like this. Okay, now let's talk about a couple of very important pieces on this graph. We said when x is 0, we have an undefined value. That means you have an asymptote there. That's called a vertical asymptote. And your vertical asymptote is at the line x equals 0. It crosses the x-axis at 0. We have an undefined value at x equals 0. We also have a horizontal asymptote at y equals 0. Okay, we have a horizontal asymptote at y equals 0. Because we said, no matter how far I go to the left, negative 100, negative 1,000, I am never going to get to 0. And same thing here, no matter how far I go out. If I go out to 8, I get 1/8. If I go to 10, I get 1/10. If I go to 100, I get 100. It just gets closer and closer but never crosses. So I have an asymptote. Okay, I have an asymptote. So what's my domain and range? What's the domain of this? Well, does it go left forever? Does it go right forever? But it can't be what?
0.
So x cannot be 0. How about the range? Does it go up forever? Does it go down forever? But it's not allowed to be what? Y cannot be 0. So there's your domain and range. So those are all the important pieces of my parent function. Okay. Another important thing to know is what affects the horizontal asymptote. If I shift it which way? Up or down, right? If I shift it up 3, my horizontal asymptote is now at y equals 3. If I shift it down 2, my horizontal asymptote is now at y equals negative 2. My vertical asymptote, what affects that? If I go which ways? Left or right. Okay, so if I go to the left 3, what's my new vertical asymptote? X equals, I went left 3, so it'd be x equals negative 3. What if I went right 2? X equals 2. Okay, so do you see how that shifts? Alright, so that's what all of this talks about. Oh, and it's called a hyperbola. That's the name. Okay, you guys know that x squared is called a parabola. That's the name of that shape. This shape is called a hyperbola. It has 2 symmetrical branches. And we talked about domain and range. Okay, and we talked about the parent function. So we've talked about all that. So let's go ahead and let's get to this and let's graph it. Alright, so our first one here, let's make a table of values. And I'm going to use negative 3, negative 2, negative 1, 0, 1, 2, 3. So when you guys plug in negative 3, what do you get? Negative 4/3, which is negative 1 and 1/3. Okay, how about negative 2? What do you get? Plug 4 divided by negative 2 is? Negative 2. How about negative 1? What do you get? Negative 4. How about 0? Undefined. How about 1? 4. 2. 3. 4/3, which is what? 1 and 1/3. Perfect. So let's graph this. So it says graph the function, compare it with the original function. So think about how this differs from our original one. Do you have your graphing calculator now, or did I take it?
Yeah, it's on there. Yes.
Okay. That's right, you don't have anything written on it. That's gonna assist you in the test. All right, so now we're gonna go left 3. Okay. Left 3 down 1 and 1/3. Left 2 down 2. Left 1 down 4. Now guys, one of the biggest mistakes people make is they think the asymptote is here. Is the asymptote at negative 1? Did we shift this up or down? No. So if I were to put in negative 4, what would I get? negative 1. Okay, so you can see, yeah, it goes from this asymptote to that asymptote. And then same thing over here. At 1, I have 4. At 2, I have 2. At 3, I have 1 1/3. So it goes from asymptote to asymptote. The asymptotes did not move. I still have 1 at the y-axis and 1 at the x-axis. So does anybody see how this has changed? Because it says, okay, graph of the function, did that, compare it to the original parent function. So how does this graph differ from this graph? Do you guys see how it's different?
Yeah.
How is it different? Okay, it is multiplied by 4, but how did it change on the graph? Because you're right, the numerator is multiplied by 4, so it's just a little bit what? Stretched away from the axes. Do you see how it's pulled away from the axes?
Yeah.
Okay, so it has the same asymptotes. Does it have the same domain and range? Domain and range. So that we know is all the same. But it's just a little stretched. It is stretched from axes. That. All right. Are we good on it? I know. This has been a long week, and I think it's been a long week from the time change.
Yeah.
Yeah. Did anybody get up and see the moon last night? Was it anything to see?
It was cool.
So what time did you see it?
2.
So I woke up at like 3 and to go to the bathroom because that's what you do when you're old. And I looked out the back window and I looked for the moon and I didn't see it. And then I went to the front window and I looked for the moon and I didn't see it. And I thought I'm going back to bed. And I was like, I'm going outside. So was it like pretty much straight above you? Because I mean, like I said, I couldn't see it because I had a great picture over the lake. I'll have to show you guys after we're done. Amazing picture of the moon over the lake last night. Gosh, it was gorgeous. Okay, B, you guys ready? How do we graph it? When you start this tonight, what are you going to do? Make a what? -3, -2, -1, 0, 1, 2, 3. Now do me a favor, get out your graphing calculators. Turn your plot off because last time we graphed, we were graphing statistics, and now we're not graphing statistics. Now, you could do, I think this one's easier to do by hand, right? What is -6 divided by -3? 2. What's -6 divided by -2? What's -6 divided by -1? What's -6 divided by 0? Undefined. What's -6 divided by 1? -6, -3, okay, so I think it's easier, but I want to show you that you could use your calculator. -6 divided by x. Make sure your plot's off. Zoom what? Okay, 9 or 6, I heard both. 6, we're graphing just a normal function. Okay, so does it look like a hyperbola? Yeah, it's a little flip though, right? The other one was in quadrants 1 and 3, and now we're in 2 and 4. Why do you think that is? Negative out front. What's that negative going to make it do? Reflect. Did it reflect? Yeah. Okay, so now, second table. All right, did I get my table? Yeah. Okay, so you could do it either way, but I honestly think it's just as easy just to do that one in your head. All right, so -3, +2, -2, +3, -1, +6. Now, did my asymptotes move? No, so they are still at the x-axis and the y-axis. So when you graph it, you go from asymptote to asymptote. So sometimes I have people say, what do you mean by that? Let me show you on the next branch. Over 1, down 6. Over 1, down 3. Over 3, down 2. What do I mean by that? Sometimes students do this. And I kind of mark off on that because I'm like, do you know where the asymptote is? Is the asymptote at -1 or is the asymptote at 0? So make sure when you graph, you show me, you know it goes from that asymptote to that asymptote. Okay? Now, how did this one change? Well, let's talk about what's the same. What's the same? Has the same what? Asymptotes. How about the domain and range? Are those the same? Domain and range, what changed? But it's what? What did you guys tell me? It's flipped, or what's the math word?
Reflected.
But it is reflected. Now we'll talk about which axes. Technically it could be either one, but it's really reflected over x. Okay, reflected over x. All right, are we good there? All right, next part talks about shifting. Told you guys we shift in every chapter. Here's another one. All right, I think this gets confusing. Let me show you an example. If I give you this problem, y equals 3 over x minus 2 plus 4. What's the 3 going to make it do? Stretch those can be pulled away from those axes a little bit. What is the minus 2 with the x going to do? It's going to go right, how many? 2. And what's the plus 4 going to make it do? 4. So now, guys, when you graph this, you need to be careful, because what happens to your asymptotes? Okay, your asymptotes also went up 4 and right 2. Okay. So now your graph will be here and here. Okay, it's always in the quadrants until it's shifted. It's in quadrants 1 and 3 unless it's reflected. Okay, and that would be my graph. But of course we'd have to put a few points up there. So let's take a look at this one. Graph the function, find the domain and range. Graph the function, find the domain and range. Okay, talk to me. What is the negative going to make it do? Okay, which axis is it going to reflect over?
The x.
X-axis, okay? Does that change my asymptotes? No. What is the plus 2 with the x going to make it do? Left 2, and then what? Down 1. So my asymptotes are going to go, I'm going to take and I'm going to draw them in. Left 2, down 1. Now let's go ahead and put this in our graphing calculator. Here's the trick to putting this in your graphing calculator. -4 parentheses x plus 2. I forgot the division. -4 divided by parentheses x plus 2. Close your parentheses. Because you're dividing by the entire quantity x plus 2. Those of you with math type, it probably puts it in the denominator. Then use the right arrow key to get out of the denominator. -1. So that -1 has to be out of your denominator. Do you guys have math type on yours? Back to right plus ones. Oh, yours? Okay. Looks like mine. All right. So here's how we enter it. And now when I graph it, because I already went to Zoom 6, so it's there. All right, looks pretty good. Let's go to the table. Take a look at the table. Okay, and let's go 3 to the right of the asymptote and 3 points to the left of the asymptote. So at -5, I am at positive 0.3. At -4, I'm at 0.1. And at -3, I'm at 3. Now this is a good one to show you asymptote to asymptote because people draw it from the x-axis. And it's not the x-axis, it dips below. And then over here, we can see at -1, I go down to 5. At 0, I'm at -3. And at 1, I am at -2 1/3. But again, this branch goes from here to here, asymptote to asymptote. Now, did this one ask us for domain and range? Yeah. Okay. What's domain? So let's think about this. What is the domain? It's x. Does it go left forever? Does it go right forever? But what's x not allowed to be? So x cannot be -2. I mean, you can see that right here. When x is -2, it says error, undefined. What about y? What will y never be? No matter how much I try? -1. Because that asymptote shifted down 1, so y cannot be -1. Basically, your domain and range is everything except where your asymptotes are. So draw those asymptotes in and then say, okay, x can't be -2, y can't be -1. All right, last one. Everybody, what's happening? It's going which way? Right 1 and up 5. So my asymptote's going right 1 and up 5. One divided by x minus 1 plus 5. Graph it. This one should not be reflected, which it's not. You can see, looks like it went up 5. It looks like it went right 1. Table. Now again, I'm going to put that error right in the middle. And now I'm going to plot my points. At -2, I have 4.67. At -1, I have 4.5. And at 0, I have 4. Boy, that's really kind of flat, isn't it? But that's okay. It goes like that. And then over here at 2, I'm up here at 6. At 3, I'm at 5.5, and at 4, I'm at 5 1/3. So again, this piece goes like this. See, you guys can do domain and range. All right, what's the domain? X cannot be what? 1, because you shifted right 1. What's the range? Y cannot be what? 5, because we went up 5. Perfect. Thoughts? First aid graphing. Fair? Okay. Yep.